Hey, hey, Välkomna and welcome to the design of embedded and intelligent systems. What does this mean? Well, a design is a plan or knowledge required to build some type of system. A system is a set of interconnected components. An embedded system is some type of small computing system embedded within a larger system like a microcontroller or something. An intelligent system can be, for example, a program that is able to make good choices. And when you combine these two elements, these two parts, then you get a large number of different areas like robotics and AI and Internet of Things. So can you think of this course as basically a robotics course? Yes, for sure. It's like an extended version maybe of robotics with some generalized computer science thrown in. Why do we care about this type of thing? Well, there's actually a revolution going on right now in areas like artificial intelligence and robotics, where we're trying to build systems to better help more people. And this can be seen from, for example, the Sustainable Development Goals in Agenda 2030. There's really so many different areas where this kind of technology can be brought in. And there's a lot of money also involved. So the US, China, and Europe have brought out plans for billions of dollars to be invested in artificial intelligence. And we have problems like loneliness, for example, which costs annually hundreds of billions of dollars. If you have some type of embedded an intelligent system like a social robot, maybe you can try to help people to be less lonely, and we can really save a lot of costs and improve people's well-being. What are some of the challenges? Well, we have some great systems that are even around us today, like cars and these home assistants like Google or Amazon. But a lot of it is still sci-fi. We don't have little robots dancing around in public places or in our homes just yet. There's a trend going on right now. So people are using more and more devices, and similarly, robots and systems are becoming more and more human-like. They're becoming better able to communicate and solve simple problems where we know the rules. Some hotspots right now, I think in research, are trying to understand people's intentions when they do something. What is the underlying meaning there? And also artificial creativity and artificial emotions, like systems that can create music or artwork. On the right-hand side in this image, you can see this thing called a touch coma from Ghost in the Shell by Masamune Shiro. This is sci-fi, but it's not purely sci-fi anymore. One of my colleagues in Japan is actually building prototypes, robot prototypes of these things that can interact with people. So we really look a lot at sci-fi and take inspiration from that. What are our dreams in this area? The first is we want to help improve people's lives with this kind of technology. We want to improve people's well-being. We also want to learn about humans by building human-like things. We want to change the world with our own hands and be the first to experience something. I think this is really an exciting area, and you're very welcome to join us for this course, which will take a little peek at some of the stuff that's being done in this area. Who am I? My name is Martin, and I started my journey in Canada studying computer science and AI. If you're ever in Ottawa, there's some really nice skating. We have the world's longest outdoor skating rink. You can buy some food and coffee and stuff right on the ice while you're skating. You can sit down and have something on the ice. Next, I took the PhD in Japan at Professor Ishiguro's Android lab. This was really a great lab for developing androids and very human-like robots. And I really recommend going to Japan if you've never been there yet, because the food is really good and the culture is really interesting. So in 2014, I came to Halmstad University in southern Sweden, where I am now. And what do I do? Well, like most university teachers, teaching is just part of what I do. I am a program director for 2 master programs in computer science. I develop AI tools and also work part-time at our pedagogical center. I am an editor at a journal, and I do research. I try to get funding. I do this and that. So what kind of things can you build when you're building embedded and intelligent systems? I looked at how people tend to express different intentions. If you're happy, what will you do to express that happiness to a robot, for example? And then I developed recognition systems that could try to recognize that type of typical behavior, like, for example, smiling or patting a robot on the back. And then I tried to use that in robot systems to give people entertainment or enjoyment, to make people feel good, basically. Now, this is that was a first prototype, a first humanoid robot prototype that could fly. I also built robots that could express emotions through warmth or cold, or change their size, or become transparent, or have persisting messages on e-paper, or steal their energy from their surroundings, or detect you in an unobtrusive way using your breath. This robot tries to guess what you've done in the near past using thermal cameras and object recognition. So this robot would try to find itself, when it was patrolling, it would try to find itself in a mirror and then try to fix itself. Here, this robot was finding humans who'd fallen and trying to localize them on a map. This robot was recognizing people's emotions with a brain-machine interface and then trying to paint something based on that to engage in therapy. This robot system was developed to be my teaching assistant, and it would do various tasks in the classroom, like showing stuff on its screen and handing stuff to students, reminding me about stuff. So I think you now have a little bit of an idea of what kind of systems can be considered embedded in intelligent systems. Now I'll talk a little bit more about the details of this course. So this course is a 15-credit course in the Embedded and Intelligent Systems Master Program at our university. And it's usually master students who take it. We also accept PhD, and you should have a base in computer science and math to really do well in this. Half of the course is based on work in a project where you build little robots that collaborate with one another. And this is showing some scenes of last year in this video, where the students had to build robots that would be controlled by animals and try to look for resources, as in if they were terraforming a different planet, they would look for some type of resource and communicate about that. I found something, come here. So half of the course is theory, the other half. And we work on labs and interactive sections, and we also have lectures, which is what you're watching right now. So how are the lectures structured? Well, we use this development cycle as a basis for organizing the topics that we cover. So here, basically, we need to have systems that actually fulfill the needs that the users have. Otherwise, the users won't use them. And then we need to actually have some type of approach to fulfill the requirements. Then we have to actually implement that. And we have to evaluate our system. Is it doing what we wanted it to do? And then we tend to go back up and cycle around and look at our requirements and design and implementation again in this kind of cycle. So I'll talk about some basic strategies for this type of design, also looking from a system view. For design and implementation, we'll look at various aspects of hardware, software, and math, and I'll look at some statistical tests for evaluation. And we have 8 lectures in this course, actually, so we really cover a large number of different topics, each one taught by a specialist in that area. After this course, you will be able to build simple embedded and intelligent systems like simple robots. Basically, you'll have a very broad range of knowledge that will make you useful in many different areas. You'll also get chances to try to become better collaborating, to be creative, and to go deeper into areas that you're interested in. For example, at the end of the course, you'll know the difference between all of these terms that are listed here, like waterfall and agile. And so, what are we waiting for? Let's get started. Thanks for watching this first episode.